Our topic today is right here, arithmetic sequences. Now it's spelled arithmetic, but people usually pronounce it arithmetic, just for your reference. Now what an arithmetic sequence is, for example, is something like 1, 3, 5, 7, 9, ... Or it could be something like 2, 7, 12, 17, 22, ... Or some people think of it as a linear sequence, meaning there is a constant difference. So to model our first example, look right here. It says find the 8th term, so I'll highlight that, of the arithmetic sequence whose first term is 4, common difference is -7. So essentially it's saying A1, the first term is 4, and every jump after that, so if you imagine it as a sequence, it would be -7, so it'd be like -3. Then it would be -10, ... And we're wondering, what is the 8th term? So clearly one way to do this is to brute force it, or you could just keep subtracting 7 every single time. But instead I'm going to teach you a formula that makes it much easier. And what we're going to use is the general formula. It's a sub n is equal to a1 plus n minus 1 times d. So right here is your nth term, meaning the term you want. That's your first term. This is your term number. And then right here, your d, that is your common difference. So first I'll show you the mechanics, and then we'll kind of talk about why that works. So let's say we want to do it here. We want the 8th term, so we want a sub 8, 4 plus 8 minus 1. The difference is -7. Let's not work it out. 4, that's -49. And there it is, -45. Now, of course, I don't want you to just simply memorize it and not really know what you're doing. So I'm going to break down what's actually happening right here. So to show you what's actually happening, what if we did it more conceptually? The first term is 4. The second term is -3. But don't think of it as -3. Think of it as 4 minus 7. The next term is 4 minus 7 minus 7. The next term is 4 minus 7 minus 7 minus 7. So look at the pattern here. The first term has no 7s. The second term has 1 7. Third term has 2 of them. Fourth one has 3 of them. So if I generically write the nth term, notice how they all have this 4. We're at 4 minus, or maybe I'll make that a plus. It might be easy to see it. Plus -7 times, and how many 7s are there going to be? Well, again, look, on the fourth term there are 3. The third there are 2. So if they're n, they're going to be n minus 1 7s, meaning 1 less 7 than the term number. And right here, we can see we just derived it. This is the general formula. And this links directly to what I showed you right here. Okay, so that's where it comes from. So now let's go to here. Find the sum of the first 100 terms of the arithmetic sequence 1, 3, 5, 7. So 1, 3, 5, 7, 9, ... And then we know that there's going to be 100 terms. And we want to add up all of these. So once again, there's a formula here. So right here, we'll write the sum formula. That's S sub n is equal to n over 2 times a1 plus an. So basically, that n is your number of terms, pretty similar to this term number here, just another way of thinking about it. A1 is your first term, and an, or a sub n, is your last term. So again, mechanically, I'm going to show you how it works, and I'll talk about the theory right after. So the formula is as follows: S sub 100, 100 over 2 times the first term, which is 1, plus the last term, which would be a sub 100. So all we got to do is figure out this thing. So to figure that out, okay, we got to go inside then. We got to figure out the 100th term using the work we just did. So look back over here. The general formula will help you find that. So to find the 100th term, I need the first term, which is 1, plus n, which is 100, minus 1, and d, it's going up by 2 every time. So now we keep going. 1 plus 99 times 2, that would be 199. So now we take this, plug it in right there. This is going to be 50 times 200, and our sum is going to be 10,000. And this is our answer. Okay, now of course I want to show you like what exactly just happened, because it's not enough to just understand a formula as something is memorized. So to really understand, let's say I gave you this thing, 1 plus 2 plus 3, all the way to 100. And I told you, add up all these numbers. What you want to do is imagine this is like a straight line, but instead of a straight line, imagine we cut it right here. So now it's 2 pieces. At the top, we're going to write 1, 2, 3, all the way to 50. That's that piece going down. And if I go back up, it's going to be 51, 52, dot, 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 100, 99, 98. So imagine this line of numbers now broken up. Here's half of it, here's the other half. Now I'm going to get rid of these lines here and put them a little closer. Now notice something interesting happening when I put a plus here. They all equal the same number. They're all 101. Which means I can easily find the sum of this pretty hard problem by just taking one of these 101s, let's just grab one of them, and think, well, how many pairs of numbers are there? Well, that would be 100 over 2, or 50, because there are 50 numbers here. So that would mean the sum is 5050. That's kind of the theory behind where this formula came from. Okay, we have 2 more examples. Okay, once again, we have our old stuff coming up. Remember, that's called summation notation, or sigma. So we got to sum up this whole list. And now it looks complicated, but remember, all we need for this formula is the number of terms, the first term and the last term. If you're given this, we can easily know how many numbers there are. Starting at 1, go to 25, so there must be 25 numbers in there. For the first term, just plug in 1 right there, so that would be -4. And for the last term, just plug in 25. So 5 times 25 minus 9, that would be 125 minus 9. That's 116. So plug that in right there. And that's going to be 25 over 2 times 112. From here, you can use your calculator, and you're going to get 1400. So right there is the sum of this thing. And notice how we can just use our old formulas that we just talked about to calculate this pretty easily. Now I'll go to the final question. Find the 22nd term, or t sub 22, in which the second term is 13, the fifth term is 22. Okay, so I'll put a blank. That's our first term. Here's our second term, it's 13. Our third term, our fourth term. Here's our fifth term. So I'm just going to write it out for us. So here's the situation. We know this one, we know this one. We got to figure out ... what t of 22 is. So that's the goal right here. So a couple ways to think about this. One is to logically kind of deduce what to do, because I know with each jump, it's a common difference because it's arithmetic. So I know I can just keep adding d until I get there. So 13 plus 3d should equal 22. So 3d should equal 9. So look at that. D must be 3. So there's method 1, kind of logic. Now here's method 2. You can use slope. So slope meaning, think of this as a coordinate. So y1, 22, minus y2, which is 13, over the fifth term minus the second term. So basically using your slope formula, and then we get 9 over 3, which is 3. So here's our common difference. So the two ways you can do it. Kind of logic it out with a linear equation, or use slope and basically use a slope formula to get your d. Now once you have d, we can easily find the first term. Because if the second term was 13, that would mean the first term must have been 10. So now I can use my formula right here. I want to find the 22nd term. I know the first term was 10, and n is 22, and our common difference is 3. So 10 plus 21 times 3, that is 10 plus 63. Our answer is 73.